Hey y'all, this video is going to talk to you about heat transfer and what that is all about. So, we've talked that heat is a form of energy. We can tell when there's an increase in heat energy or thermal energy when something gets hot, right? So, your stove gets hot, that means there's this increase in heat energy that's going on here. And then a decrease in heat energy means something is cold. So you're putting water into the freezer to try to get ice. That water is going to actually lose heat energy or lose this thermal energy and get cold. So temperature and heat energy are not the same thing. Temperature is a way to measure the hotness and coldness of an object. It's not a measure of heat energy. So if something, you know, if the temperature of a pan increases by 5 degrees, we don't say it absorbed 5 degrees of heat energy. That's not what we measured. We just measured how hot or cold it was. In order to get a measure of heat energy, we actually have to use a special equation that I'll explain in just a moment. So one of the most probably popular ways of being able to see heat energy is through infrared. So you know that I know you've seen these in movies before. So red indicates that something is hot. Purple or black indicates that something is cold. So when looking at a running car, the engine is running really hot. It's producing a lot of thermal energy, hence why the hood of the car, the tires, this kind of even the dash is revealing this red energy or this red colors because there's a lot of thermal energy going on there. And then of course the top of the car and the back side of the car is a lot cooler. There's no engine running back there. You can tell the background's pretty cool as well. Okay. So every object that exists has a specific heat. Now, what this specific heat is the amount of energy required to raise the temperature of the object. And it's the amount of heat energy required to raise the temperature of an object by 1 degree Celsius. Water has a very high specific heat. This is why I've got a picture here to talk to you about it. Water actually requires a lot of heat to actually raise its temperature. This is why it's a good thing that humans are made up of mostly water, because that means that our internal temperature doesn't change a whole lot when we encounter different extremes. Right? We don't want our body to rapidly heat up. That would be a big issue. We wouldn't want it to rapidly cool down. That would be awful. So the fact that water has this very high specific heat is super important for life on Earth. If it weren't for water and its very unique properties, life on Earth would not exist. And specific heat is just one of those properties that makes water really special. So again, water has a high specific heat, which means that it takes a lot of heat energy to raise the temperature. Now here's that specific heat equation, or the thermal energy equation that I was talking about earlier in this video. This is the equation that we use to determine how much heat an object has absorbed or how much it has released when there is a temperature change. So, and I'll go through each of these variables individually. So Q is what we're looking for. We're looking for the amount of heat energy there, okay? So Q is just the amount of heat energy that we're looking for. M is mass. So the amount that you have of an object affects how much heat energy it's going to absorb. A bigger object might absorb more or less than a smaller object. We'll be exploring that a little bit. C is that specific heat that I was talking about, that very special property that every object has that's unique to that object, or the composition of the elements that are in there. So specific heat is the amount of energy it takes to see a change in temperature of an object. And then we see this triangle T. That triangle is actually delta, so we say delta T. Whenever you see delta in any type of equation, it represents a change. So there's this change in temperature. And so the actual way that we measure delta T is we take the final temperature minus the initial. It's always final minus initial. It's never initial minus final because we're looking for the change in temperature. So we look at the final minus initial. Okay. So the process used to measure the amount of heat involved in a chemical or physical process is called calorimetry. So anytime that you hear calorimetry, you know that the amount of heat is going to change and that you're going to need to measure it. So you'll be having a calorimetry lab. You'll use a calorimeter to figure out how much heat is being exchanged. You'll do calorimetry practice problems, which means you're going to be measuring how much heat's been changed by looking at word problems and solving them and figuring them out. Okay, so when you hear the word calorimetry, it just means that we're looking at a change in the amount of heat of an object, the amount of this heat energy. So let's do a calorimetry problem or a specific heat problem together. Okay, so let me get my pen ready. And we'll see what this question is asking us. So it's asking us how much energy would it take to raise the temperature of 500 grams of water in a kettle from 21 degrees Celsius to 100 degrees Celsius. And the specific heat of water is 4.18 joules per gram per degree Celsius. So we have to recall our specific heat equation, which is Q is equal to M times C times delta T and then I'm also going to kind of write down here that delta T represents temperature final minus temperature initial. Okay, so we'll need to find each of these things. So first off, it's asking us how much energy would it take. So that means we don't know what this is. This is what we're looking for. So this is a big old question mark. The next thing is it says how much energy would it take, which means looking for energy, to raise the temperature of 500 grams of water. So the next bit of key information they give us is the mass, which is what we're looking for M. So M is equal to 500 grams. So we're looking to see how much energy it would take to raise the temperature of 500 grams of water in a kettle from 21 degrees Celsius to 100 degrees Celsius. So we're starting at 21, which means that's our initial number. So this is 21 degrees Celsius to 100 degrees Celsius. So we're going to 100, which means that is our final temperature there. Okay. And then last thing it tells us is that the specific heat of water is 4.18 joules per grams per degree Celsius. So for this is 4.18 joules, and this is how you write the unit, per grams times degrees Celsius. Okay. So we've got all of our information. We've got our mass, we've got our specific heat, we've got our final temperature, we've got our initial temperature. So let's kind of put this all together into our equation. Okay, so again, we're looking for Q, that's our unknown. Our mass is 500 grams. Multiplied by 4.18. That's our specific heat. Times our final temperature, which is 100, minus our initial temperature, which is 21. Okay. then we can just type that all into our calculator. I'm going to type it into my phone calculator. It's what I have on hand. I still haven't gotten batteries for my other calculator. So 500 times 4.18 times 100 minus 21. Remember to keep those parentheses around 100 minus 21 or you won't get the right answer. And I get 165,110. And our unit for this is actually joules. Energy is always measured in joules, okay? And actually, if we look at our units here, let me work it out for you real quick. Grams, this is times joules per grams times degrees Celsius times degrees Celsius. This is actually what it would look like. So this degree Celsius with this degree Celsius would cancel out because it's degree Celsius divided by degree Celsius. And then same thing here. You got grams divided by grams, which means we're left with joules. So joules is our unit. So at the end of this problem, we get that water had to have absorbed 165,110 joules to be raised from the temperature of 21 to 100, which is 79 degrees.